This is Dilish Patel with the eVSM Group. Today we've been joined by Art Thomas, the Vice President of Operations at Aero Industries. Art, a very warm welcome and thank you for discussing the layout effort at Aero with us and your use of spaghetti diagrams within that. I think I visited with you at the Aero facility in Indy perhaps 4 years back when you had a consulting role there, and I believe you joined the company about a year later. And at this point, you're the VP of Operations within the organization. If you could start us off by giving us a little background on what Aero produces, please.
Their main focus is on transportation, flatbed products, basically an upfitter. We have a line that's called the Conestoga, which is covers flatbeds for hauling long, steel, wood, whatever. So you can load from the side, but yet it's covered. So you'll see those going down the road. There's quite a few of them today, and okay. Aero was first to the industry, but there's a lot of competition out there now. We also do the boxes that go underneath the flatbed, the aluminum boxes. That's another product line we have. And then our third product line, or I would say, is dump trucks, roll-off containers, dump trailers, side dumps, front dumps, all different types of covers that we produce for that product as well.
And I know you've been using spaghetti diagramming for a long time. It's one of the simplest lean tools out there. If you can give us a quick intro to it and what's the main goals and what would drive you to using a spaghetti diagram?
Well, yeah, I have been using them for a long time. One of the values, the initial values is that you can see, just visually, you can see the confusion that happens with the movement of product and people. So at just a plain visual level, that's, you can see that, you can start noticing where there might be bottlenecks just based on the space where the traffic is. However, specifically, because of the tools that eVSM has, I've been using it now for about 6 years to also really quantify what kind of savings we're looking at and being able to drive down to the data side and being able to look and say, okay, what does this really mean and the number of feet we're moving and all of that. Also being able to use the color coordination allows us to focus on certain products where we can see, hey, this product's really where our opportunities lie. So as with anything in lean, you have to still develop priorities of what you want to go after unless you have unlimited resources.
Yeah.
So this is a great tool to be able to help you identify what priority to work on.
Fantastic.
So, yeah.
And then what was the situation at Aero that led you guys to apply it, and when did this project begin?
So Aero started basically in this particular building in 2004, and at the time that it was probably a great layout in 2004. However, over the last 17 years, business has changed as far as what products we produce, where they go, how many we produce of each product. And so in 2017, when I was still a consultant, we actually started this project. However, as a consultant, then I didn't have a whole lot of ability to push it too far. And so we done the initial diagram and the initial data collection at that point. And then, so now that I've been here a couple years, we were actually going to hold off on doing the plant layout until next year, or this year. But last year with COVID, we decided to use up resources and go ahead and get it completed. So the driver, I guess, would have been we knew that there was lots of opportunities out there. We just because of how many changes the companies went through in 17 years.
So who was involved in doing the spaghetti diagramming, and how long did the whole thing take?
So, I would say, well, first of all, we had our plant manager was heavily involved. We had our continuous improvement person was heavily involved. Our manufacturing manager was heavily involved. And then from there, it went down to department level supervisors on, okay, here's what we're thinking, that kind of a thing. So there was so I guess, this, the initial spaghetti diagram that we did in 2017 took us about, and you got to remember it was a consultant. So I was training while I was doing it, but I would say maybe 4 hours to do the initial spaghetti diagram. And then I would say this last one was the improvement one, because we went through several iterations. I would say it was probably 6 to 10 hours of actual time. Again, we would do one, we would say, oh, look at all this opportunity, we'd leave it on the table, and they would go back and modify, and we'd meet back again on the new design.
Now, were you trying to map material flow primarily? Was there a leader product? How did you focus in on what it is that you would spaghetti diagram?
So in our case, we did all the products because they're all in one building.
Okay.
And so the interaction between the products is important. There are cross flows between the value streams. So in other words, the value streams are not as clean as I would like them because we don't have the ability to duplicate major pieces of equipment. So some of those things have to flow across departments. So that being the case, that interaction had to be dealt with. We did focus though totally on the material movement. So we did not really talk. Basically, if the material was moving, we included it.
Okay, got you. That's good. And then
yeah, so we started off and we would get let's say an hour into it, and all of a sudden we would see, because one of the things that you don't always understand is how many trips you're making until you really start thinking about it. So a space you may say, well, that's only 15 feet, but then when you start realizing you make that trip between say 5 or 10 employees, maybe they make that trip 100 times a day.
Okay.
Well, now that becomes 150 feet. Well, when you're out there designing it, it doesn't look that bad until you realize how often you're going to have to do that.
The frequency of the whole thing.
Yeah.
No, that makes sense. So you created a current state diagram first of
Yes.
how it works today, and then how did you go from that to thinking about what the future layout might look like?
Well, again, the nice thing again with eVSM, we were able to really focus in on where where the amount of the travel really was starting. So, for instance, bulkhead, which is a title we used for some of our products or one of our products, was a huge portion of what we had as far as movement. And in addition to that, it was a large piece of product. So now when you're looking at moving it, you're not just talking about somebody walking with a little cart. You're talking about,
okay.
A 300 or 400 pound item that you're pushing around the plant.
Oh, okay. So there's the trip frequency, and then there's the severity. Like a 1 foot of moving, that thing counts like a lot more than 1 foot of moving, as you say, something that someone is carrying. That's
Right.
great. And then you created a future state. You generated some ideas. Was that a team effort? You guys brainstormed it together?
Oh yeah. I mean, to be honest with you, none of the ideas came from me as far as the improvement. My job, even as being, again, I was still doing the spaghetti diagram because I'm a big believer in it, but it was simply for me was getting the visibility to the team. They made those decisions. They realized when they seen it, yeah, we can do better than that. There's better options. And so it drove them. It's interesting because you're doing a continuous improvement project, but within the continuous improvement project, we had continuous improvement of our project. And so I think that's what's so cool is that you actually are able to look at this and go, okay, yeah, we're going to make this great move. We're going to make all these results. But because we can look at the data as we're designing it, you actually have iterations within iterations where you're saying, oh, sometimes we'd only sit here for 20 minutes and we go, oh man, there's a huge glaring error and that we got to fix. And they'd say, let's just forget it. We'll come back tomorrow or next week or whatever. And so yeah, I mean, there was probably, I don't know, there may have been 40 iterations of
Wow.
starting and stopping, but the nice thing was we had the data to go with it. So this was our initial shot back in 2017 of, trying to look at our current state. And one of the things you'll notice here, and over here to the right, you can see how we divided them up. You can see here was a bulkhead. This was the brown here was some ancillary. This here was the front bow, was the black. This here was the eye bow, was the yellow. Again, these are all names that are specific to our industry. But and then you can see here as our layout went, you can see everything in our entire building was basically going down this one aisle. And so there was so many issues with this beyond just, the movement, because some of these things, it's hard to even see, but they're going back and forth. But the safety issues of everything coming through here, much of this traffic was fork truck traffic. And so again, we did not have any fork truck accidents, but as a prevention, we didn't want fork trucks going down through an area where there was also so much foot traffic. Go ahead.
Well, it was just interesting that you brought safety into it, because I've been reading some recent articles because of COVID, where they're using spaghetti diagramming inside stores and things like that to reduce congestion, right? To keep the social distancing aspect. So it's interesting what's happened with this little tool in the last year or so too, from a safety perspective. Yeah, go ahead, Art.
So we, when you look at this, it's like, well, this, we all know this doesn't look good. And then of course we were able to go over to the right and be able to, look at the data of what's really happening. And so between the two, you can see here the data, we started being able to get, the amount of feet that it was traveling per day. And so here's some of the iterations that you can see we went through that were just, again, they were just a few minutes sometimes. Or we'd get to one like this and we'd say, wow, look at all this green. This is really a lot of movement here. So, we probably need to look at that and see why it's doing that. And so, then this actually was a future state proposition, one of our first future states that we came up with. And you can see we went from 10,000 per day to 6,000 per day. That's feet and movement. Now, again, this was simply our, kind of our first thing. This was still back in 2017.
Okay.
So then we went, I don't know how much, do you have any questions about this as far as what we're looking at here? If not, I can go to the new one.
Just to summarize it, you've taken a floor plan and you brought that in as an image, I'm assuming. You put a scale on it, and then the blues are places that you created these paths between, and the color coding represents the different products.
Yes.
And the Excel out from eVSM has given you the distances. You must have added like trip frequency to that to be able to get overall distances, I guess, eventually, right?
Yeah. So what we did, and you'll on the outputs on the new eVSM, it actually lets you put the frequencies in there. So we actually, in this particular one, we had to do it as a separate thing, kind of saying, okay, so on our spreadsheet, we just started putting in how many times it happened. But on the new one, on the new layout, when we did it this past year, we were able to put that data right into the system. So,
okay.
So yeah, the blue represents actual workstations. I would say we got pretty detailed. We weren't down to the cell flow, meaning within a cell, we really didn't get down to that level. We probably will as we continue to improve, but at a macro level, I would say this is more detailed than probably we had to do it, but I tend to be a person who likes to get details, so maybe I overdo it sometimes.
Yeah, it's interesting. So there's, I think you move actually very quickly, knowing you over the years from the initial data capture. I think they call it digitization. This week I came across a new word called digitalization. And I thought, what is this? Is this just a different variance? But apparently that's about doing something with the data. So digitization is collecting the data and, there's massive collection systems. But the harder part is the second part, that digitalization is, okay, I see it. Now what do I do with it? And, you've always moved very fast with that second step.
Yeah, and I'm such a believer in this process that there again, I didn't just teach it. I'm practicing what I teach because I just have a lot of belief in what we're trying to do here.
Perfect. And what's you were playing around with some different future states. What's the state of the project now? Have you started redoing the layouts, or where are you at with the project?
The layout is fully implemented.
Great.
We moved every machine in the building except two, I believe. So every machine, every rack. It was massive amount. I will also just kind of throw this in here that the nice thing about this is it did start our project planning as well, which we spent a considerable amount of time planning the sequence of down to electrical boxes that had to be moved and what sequence they should be moved in. So
wow.
The nice thing is this also gave you somewhat of a relevance that you could kind of see, here's what's going to be moving where and all of that. So you could kind of say, well, so what we did a lot is once we started the planning of the actual move, we used the spaghetti layout to kind of look and see, okay, yeah, this is moving, but what's coming in here? And, again, the sequencing of the move was very, very critical as far as implementation.
Yeah, I can imagine. And you're trying to plan your downtimes of the different areas and all the rest of it, right? It had to have been tricky.
Yeah, we tracked our downtime, and again, it's a little difficult to do real accurately, but from our calculations, as far as actual time that we were not able to produce some product, okay, meaning we did not have an alternative, we just were down and we could not make product for our customers, was about 2 hours. The rest of the time we either had already, so a lot of things what we did is, again, with the sequencing, we would set up, if we had two machines, one was set up and operational before the other one was taken down, that one was left up and operational. So we only had 2 hours. And again, I'm sure if we looked at the actual output, it did go down during that time just because, moves going on. But yeah, it was very well implemented.
So for just for the audience who are looking at using this, what do you think the learning curve is for spaghetti diagram in particular and using the eVSM toolset?
Well, first of all, it's you're really using Visio and Excel. So if you've got any background with Visio, your learning curve is very, very short. I'm going to say, if you're used to using Visio, I can show you how to do this in 25 minutes. And I would say within an hour or so, you're going to be comfortable doing it. And let me give you a demonstration of how this actually occurred, especially in the new one, is the gentlemen that were in here working on it with me multiple times, because they were the ones who had more understanding than I did. They would jump into the driver's seats, so to speak, and they were doing the spaghetti diagramming. Neither one of them had ever done spaghetti diagram or used eVSM before. But
that's cool.
After watching me for several, times do it, they wanted to just get in and do it because it saved a step of us trying to translate back and forth, and they knew what they were doing. So
No, that's
Um,
great. That's great.
so through this process, two other people besides myself actually were doing the spaghetti diagramming.
That's fantastic. And if you had to look at the bottom line benefit to the company, how would you summarize that of this whole activity?
Well, let's. Can you see the new layout now?
Yeah.
There on the screen. So this is the new layout, and as you can see, it's totally different than what we were just looking at. And so you can see, first of all, I just want to show there's no fork trucks. Basically, past this row here. Okay, so we have fork trucks here. This is where our raw material comes in, and we have fork trucks. This is actually product that we're slowly trying to reduce inventory on. And then we have an aisleway here, again, no people, and then this last aisle. So there is no fork trucks moving at all through our areas where our people are. And so we've greatly reduced the chance of a fork truck incident. So, and you can also see that from a congestion standpoint, we've actually reduced congestion, a lot.
Yeah. Yeah, that looks clear from just looking visually at the diagram.
Right. So, yeah. So in general, this has been. You can just see it's better. It's hard to show in this picture, but also the sight line. People have walked in this building that have been coming in here as suppliers and vendors, and the first thing they tell me when they walk in my office is that plant looks amazing. You can see everything when you walk out the door. You can literally see the entire facility. And so that's the other thing, is just the communication, the site. Again, when you increase visibility, you increase communication. And so as people can see what's going on, they're more likely to tell you and see what's wrong, see what's right, whatever it is. So part of the goal here was to increase visibility. So when you talk about the actual comparison, again, the data is super handy here. So our proposed layout, which is the one we went with, I'll just go down here and you can see versus our previous one was 100. Just here it is, 95,516.
2x.
So we had about a 55% improvement in actual movement of material. Again, as you can see through here, and you can see how we moved, from different stations. We were basically counting the number of trips we made. So we're moving materials. This isn't just people going to the bathroom or break room or whatever. This is material.
Right. Oh, that's fantastic. So, Art, if I just to close off, lean practitioners generally who would be looking at this, they're probably familiar with spaghetti diagramming in general, the old way where you used to have paper and then used to sketch over the top, and a lot of value in that, in the sense of you can still see where the high congestion zones are and things like that. But if you had to leave some takeaways for them on this combined kind of paper plus electronic approach, what would you tell them?
Well, I think the first thing I would say is the iterations are much easier, so you can save every iteration and look at what you did and what you came back with. If you're doing this on paper and you are using some way of erasing or whatever, it becomes a mess because I've done it and I understand it. However, what's nice about this is you can start off with your full thing or whatever you want to do. You can do as many iterations as you want, and there's no negative effect to what your outcome is. In other words, you're not spending time doing the spaghetti diagram. You're spending time actually making the improvements. So the iterations, that's the big part, is that, if I say, hey, what about it? What if we did this? What if we did that? Well, you try to do that on paper and it just becomes, it's almost useless to try it. But So that's a big thing, is the what if iteration scenarios that you can do with this. So we did that multiple times. I don't know how many times. I'm going to say hundreds of times we ran the Excel output to see where we were at. What had we done? Did we gain? Did we lose? So that's the first thing I would say. Then the next thing to me is, at the end of the day, when you have to make this presentation to the people who have to spend the money, while it all sounds good, and I get the theory of, you know, continuous improvement, at some point you have to convince somebody that you want to spend money. And when you do not have any data and all you have is a picture, while the picture's, you know, probably powerful, being able to come up with data and say, look, this is a 55% improvement. Well, you're going to have a hard time doing that on paper. And so to me, that's the other thing, is most of my career, I've had to sell my ideas, somebody's ideas, to somebody. And so, again, I think that's huge, is being able to actually get the data, present it in a meaningful way, and know that the improvements you're making, and also it establishes an expectation of what you really should get from this, being able to measure the output. So anyway, I think those are the two things I would say just off the top of my head that are just so much better with this method than paper.
No, that's fantastic, Art. Hey, I really appreciate you sharing this case study. I think it's work that a lot of people could take to heart, and it has a lot of application. And as I said, I've read about 3 or 4 COVID-related spaghetti diagram usages, and I'll pass on a couple of links to you. I think you'll find them interesting as well.
Okay.
All right.
Awesome.
I really appreciate it, Art, and we'll touch base again. You've been an advisor to us for many years, and so look forward to further chats as we all move out of COVID and better times together.
All right. Sounds good.
All right.
Thanks, Delish. Okay.
Thank you, Art. Take care.
Bye.
Bye-bye. Bye-bye.